Students, now we are entering into Unit 3. So in Unit 3 we are going to discuss about structural behavior of materials. We'll discuss how the material behaves when a structural load is applied on the materials. First, design. What do you mean by design? Design means it is a process of determining location, material and size of structural elements to resist forces acting on a structure. So it can be explained in a method that when we have to construct any material or any building, we have to check how much load can a material can withstand. Withstand means how much load can a material bear due to any forces acting on it. So here, what is the role of a structural engineer? Structural engineer designs the structural systems and structural elements in buildings, bridges, tunnels and other civil engineering works. So what is engineering design process? First we have to identify the problem. Then we have to propose alternative solutions. So designing means not only giving one solution, we have to give alternate solutions. One type of solution can be research past experience. So we have to see if you have any problem, whether that problem has been resolved in any previous experiences. So if it was resolved, you can take some information from their experience, or else you can come with a new idea. Then preliminary design of most promising solutions. So we should have a basic design with advantage solutions. Then you have to analyze, design one or more viable solutions. So you have to design in a way like we have to analyze and design in different ways, like we have viable solutions. Then we have to testing and evaluation of solution. So how can we test and evaluate a solution, or evaluate the solution which we got from analyzing and design? We can have experimental testing or field test, as you generally do in laboratory. Experimental testing, if we go onto the site and do tests there, that's called as field tests. Next one is peer evaluation. So peer evaluation means if you have done designing, it can be cross verified by the person from the same department to improve the quality. You can take some suggestions from him, or else he can guide you to do in much better way. That is called as peer evaluation. Next, build solution using available resources. So design engineer has to build some solutions within the available resources or using available resources. What are the general available resources? Materials, equipment and labor. Labor means men to work. Now coming to forces in structures. So what are the forces you can find out in structures? So forces acting on structures. What is the forces? Like any cause which tends to alter the state or rest of a body or its state of uniform motion in a straight line. So we have different types of forces. Forces induced by gravity. So dead loads and live loads. What is a dead load? Dead load is a permanent load, self-weight of structure and attachments. Live loads, moving loads, example occupants, vehicles, etc. So these are the loads induced by gravity. Vertical loads. Now forces induced by wind, forces induced by earthquakes, forces induced by rain or snow. Induced means forces due to wind. forces due to earthquakes, forces due to rain or snow, fluid pressures, and others. See, here we have a pictorial representation. If you have a structure like this, forces induced to gravity, it is a vertical load, it acts in the direction of the gravity. Wind and earthquake loads, it acts in lateral direction. Lateral direction means horizontal direction. If a horizontal force is acting in this way, there is the structure can slide. If it moves from the original positions to another position, this is called a sliding movement of object in the same plane. Overturning, so it stands on this corner and it overturns, it will rotates, like it overturns. There are two types of withstanding to these forces can be called as stability. So now, what are the general forces on structural elements? So as you already heard these words, tension and compression. Observe here, one end is fixed and another end we have a load of 100 pounds. So generally here this force is with fixing this, and this side this force applying in this direction. So here this force will apply in this direction and this force will apply in this direction. So due to this fixed movement, fixed end, we have this type of force. So totally this force can be known as tension. See, here you have a fixed end, so it is giving some resistance here in this direction. So 100 pounds weight is acting from the top direction, so it is acting in downwards and it is acting in upwards, so downward and upward. So these material will face a force compression. So these are the general forces on structural elements. Like if you have, these are supports, we have two fixed supports at two ends. A beam has been laid on these two supports. If you apply a load, this beam becomes like this, like it deformates like this. This is called as bending moment. At the same time, if a material is there fixed on two supports, if we have rotatory forces in opposite direction, this is rotating in this direction and this is rotating in this direction, this force is known as torsion. So we have typical structural elements. This is known as arch. So if you observe this type of structure anywhere, this is arch structure. So next one is, we have truss. Generally trusses are used for steel structures. See, if you have a truss supported at two ends, if load is acting in this direction, this arrow mark shows load acting in vertical direction. In downward direction means load acting in vertical direction. Now this beam will deflect like this, the dotted lines, the beam will deflect in this direction. This is called as bending. When these type of force is applied from the top, these portions, like this portion will go under compression. This portion will go under compression, this portion will go under compression, because these three are compressing. Due to this action here, this part will get compressed, and this part will get elongated. So tensile force is applied here. So this is example for trusses. So we have typical structural element. Another one is framed structure. This is general structure where we see all our buildings of beams and columns. If a force acts in this direction, these beams will bend like this, and this columns bends like this, and this beam will have deformations like this. So we have different structures. These slabs are called as flat plates. This is flat plate slabs. These are folded plates. These are shells. These are different types of structures. We know we have flat plates, folded plates, and shells. Now coming to properties of civil engineering materials. You already know the stress and strain, the forces acting perpendicular to the plane of cross section. This is cross section. Perpendicular to the plane of cross section means tensile and compressive. Forces acting parallel or tangential to the cross section, to the plane of cross section, that is called as shear stress. So if you have shear stress, we know the formula strain. So we have types of stress strain behavior. If you see this elastic behavior, we have when a material returns to its original shape when the load is removed. We have linear elastic and non-linear elastic. So this is stress strain curve is so linear. This is called as linear elastic material. This is in a curved path. This is called as non-linear elastic material. Generally steel cable will have these type of linear elasticity, and rubber and biological soft tissues will have this type of elasticity. We have next one is plastic behavior. The permanent deformation of the specimen so that it does not return to its original shape when the load is removed. So plastic behavior means if the material has a permanent deformation and it does not return to its original shape, there will be some difference from the original shape to the deformed shape. That if the material is having that type of behavior, that is called as plastic behavior. So what is elastic limit? The point where the stress changes from elastic to plastic. This is important. The point where the stress changes from elastic to plastic. If you observe from the figure C, the material shows a linear elastic response upon loading. Elastic response means this is the linear elastic response, followed by a completely plastic response. So this is plastic response. If such material is unloaded after it has plastically deformed. So if you think this material is plastically deformed, it will recover in a linear elastic manner and will follow a straight line parallel to the elastic portion. See, this is the elastic portion, this is the parallel line. This is called as plastic strain, while some permanent deformation will remain. Don't get confused. The main concept is there are different types of material. The material is sometimes it have elastic behavior. So up to this load, this material can come back to its original position. If the material is not able to come back to its original position, if there can be any change in the material length or volume or size, that type of behavior can be defined as plastic behavior. If the material comes back to the original position, that type of behavior is elastic behavior. In materials such as metals, soils, rocks, concrete, foams, bone. So we can find this plastic behavior in these types. Now coming to brittle, we have brittle property and ductile property for materials. So if a material that do not show plastic deformation prior to failure, so this type of material does not give any signs for failure. It fails at a sudden, such as concrete. When a brittle material fails, the structure can collapse in a disastrous manner. So we don't have any warnings or anything, it suddenly fails. But ductile materials that display appreciable plastic deformation, such as mild steel, overloading a ductile material will result in distortions of the structure. So you will find out some failure instructions, but the structure will not necessarily collapse. So we'll have structure will not collapse, but it will fail. So this is difference between brittle and ductile materials. I have provided you a lot of videos according to each material. If you watch those videos, you can understand what is a brittle material, what is ductile material, what are the types of forces. Everything was clearly mentioned in those videos. So I recommend you to watch those videos. So here comes to failure and safety. First, failure. Failure occurs when a member or structure stops to perform the function. So if a member is not able to withstand the load acting on that, it will fail. So we have different failures. Failure occur due to fracture, fatigue, general yielding, buckling, and excessive deformation. We'll go one by one. Generally, fracture is a common failure mode. So we have a brittle material typically fractures suddenly when static stress reaches the strength of the material, where the strength is defined as maximum stress the material can carry. So here the maximum stress which a material can carry. So if that it reaches that stress, it may occur failure may occur. In a ductile material, fracture due to excessive plastic deformation. So the plastic deformation will have more excessive, then it gets fracture. The number of applications a material can withstand depends on the stress level relative to the strength of the material, or else a material can fail due to number of applications. The material can resist once, first time, second time, third time, like that 100 times it can resist, but it may fail after 110, 120 force. So it depends upon the number of applications. When the stress level decreases, the number of applications before failure increases. So now failure due to fatigue. So in these type of failures may occur in bridges and pavements. So due to continuous loads or due to up and down loads, these type of failures occur. Subjected to repeated loadings, creating stresses that are less than the strength of the material. Pavement. The stresses applied by traffic are typically much less than the strength of the material, but repeated loadings may eventually lead to a loss of the structural integrity of the pavement surface layer, causing fatigue cracks. So this is due to fatigue. Bridges and pavements, due to repeated loadings, we may have this type of failure. So yielding is a point that failure happens in ductile materials and it spreads throughout the whole structure in yielding. Buckling. Long and slender members subjected to axial compression. Generally we see this buckling in columns. Again, I have given you a Word document which is having new words and terminologies and their meanings. All the meanings I have explained there. So if you see this, you can understand what is yielding and buckling. To understand this in much better way, go and watch the videos which I have provided for this yielding, buckling and fatigue natures. Sometimes excessive deformation could be defined as failure. Excessive deflections of floors make people uncomfortable. If you have more deflections on floors, people may feel discomfort. In an extreme case, may render the building unusable even though it is structurally sound. So this type of excessive deformation should not be there. Now, factor of safety. This is the important thing which you use throughout your civil engineering. factor of safety. Generally, the factor of safety means it is the ratio of the stress at failure to the allowable stress for design. Fs, factor of safety, is equal to stress failure and stress allowable. Failure stress of the material and allowable stress of the design. So the factor of safety depends on cost of unpredictable failure in lives, dollars and time. So money and time. Variability in material properties. Degree of accuracy in considering all possible loads applied to the structure, such as earthquakes. Possible misuse of the structure, such as improperly hanging an object from a truss roof. Degree of accuracy of considering the proper response of materials during design, such as assuming elastic response although the material might not be perfectly elastic. So these are the factors of safety. These are the factors which we have to consider, or the factor of safety depends on these materials. You can learn much about this factor of safety in design subjects, which you can learn in your further semesters. Important structural properties. Ability to withstand a given stress without failure can be defined as strength. Ability to withstand a given stress without failure. So the strength depends on type of material used and type of force applying on the material and the geometric shape of the material. If you have a material like this, if you apply tension in this direction, the failure occurs in this place. If you have a compression, the material will bends like this. This is called as buckling. The material bends like this. This is known as compressive failure. So types of structural elements: bars and cables. So these are known as bars, can carry either tension or compression. Generally these are used in steel structures. This can take compression as well as tension. So here cables, generally we will see these electric towers and telephone towers. There we use cables. Cables can carry only tension. So if you have a beam like this, which is simply supported on both the ends, if load is acting in this direction, this will have this type of deformation, bending. So when a beam bends, the bottom portion of the beam will have tension and the top portion of the beam will face compression. So when a load applied in top direction, the bottom part of the beam will go to will affected by tension, or the force in the bottom portion is tension, and here the beam tends, the material gets compressed. So stability, if you have a frame like this, if a load is acting in this direction, the material can deform like this. This is a raking failure of pinned frame. These are pinned frames. We have different types of frames. You can learn later: fixed support and roller support and pinned support. Generally we'll see these type of supports in steel structure. If you have a steel structure like this, if you apply force in this direction, horizontal lateral force, the frame can face this type of sliding or movements. So these are called as braced frames, and these are infilled frames. Already frame is filled with some material. These are rigid joints, not a pinned one. This is welded, or in this fixed one. So these are rigid joints and solid joints. So these are the different types of lateral loads. Okay. So I think you can understand something what we have covered here. We just gone through design, structural engineering design process. What are the forces acting on structures: vertical, lateral, sliding, overturning. What is tension and what is compression? So what is bending and what is torsion? Arches, terraces, frames, and so you can understand these topics. When you see all those videos, you can have a better understanding. I have already uploaded a quiz. You have to create a new Google account, like Gmail account. With this Gmail account you can log in and complete the quiz and answer all the questions before you come to the class, because I'll be receiving all the information, and once you fill it, I get the information that you have filled so and so. So be sure that you will complete the quiz before you come to the class. Thank you for listening. See you in the classroom. Have a nice time.